we are discussing some standard operations used in fuzzy sets. We have already discussed a few and now we will be discussing a few more. Now, let me start with the concept of multiplication of a fuzzy set by a crisp number. Now, here, so what we are going to do is, we are going to multiply a fuzzy set. For example, say the fuzzy set can be written as follows. Say A x is a fuzzy set. Now, this particular fuzzy set I am just going to multiply by a crisp number, that is d. Now, if you see how to write down this. So, d multiplied by A x is nothing but x, such that you have got the membership function value, which is nothing but d multiplied by mu A x, x belongs to capital X. Now, here the range for this particular d, generally we consider the d is greater than 0 and less than equals to 1.0. Now, my question is, why do you need this? We need this particular concept because if you want to optimize the shape and size of the membership function distribution, so we will have to consider this particular concept of multiplication of a fuzzy set by a crisp number. Now, let me take one numerical example. The things will be made more clear. Now, supposing that I have got a fuzzy set A x, which is nothing but x 1 comma 0.1, x 2 comma 0.2, x 3 comma 0.3, x 4 comma 0.4. So, this is a fuzzy set, a discrete fuzzy set having 4 elements x 1, x 2, x 3 and x 4. And supposing that the crisp number d is set equal to 0.2. Now, if d is equals to 0.2, now d multiplied by A x, so this particular thing will become equal to x 1 comma, so d multiplied by, so this particular mu value, so d is 0.2 multiplied by 0.1 and this is nothing but 0.02. So, corresponding to this particular x 1, so this will be d multiplied by mu and this will become equal to 0.02. Now, following the same procedure, I can also find out what will happen to corresponding to this particular the x 2. Now, here corresponding to x 2, the membership function value is 0.2 multiplied by the d is 0.2. So, this is nothing but 0.04. So, corresponding to this x 2, we will have 0.04. Similarly, corresponding to x 3, we will have 0.3 multiplied by 0.2 and that is nothing but 0.06. Then corresponding to x 4, we will have 0.4 multiplied by 0.2 and this is nothing but 0.08. So, corresponding to your x 4, so we will be getting 0.08. Now, let us try to understand the physical significance of this particular your multiplication. Now, supposing that I am just going to draw the discrete fuzzy set, that is A x. So, let me just draw it here, and element wise I am just going to write down say the membership value. So, this is mu and mu varies from say 0 to 1 and here let me write down say 0 to only say 0.5 and we have got the values up to 1.0. So, this is corresponding to say x 1, this is x 2, this is x 3 and this is your x 4. So, this is the direction of x. Now, if I consider the original fuzzy set, that is A x, so corresponding to your x 1 I have got 0.1. Supposing that, so this is nothing but 0.1, this is 0.3, this is 0.3 and this is your 0.4. Now, corresponding to x 1, so I have got say 0.1, so I am here. Then corresponding to x 2, so I have got 0.2, so I am here. Now, corresponding to x 3, say I have got 0.3, so might be I am here. Okay. Now, this is say 0.3 and corresponding to x 4, so I have got say 0.4, so might be I am here. Now, if this is the situation, so this is the distribution of your A x, that is the fuzzy set A x. Now, if I just multiply by d, where d is equals to 0.2, so corresponding to x 1, so I will be getting 0.02, so might be I am here. Then corresponding to x 2, so I will be getting 0.04, so might be I am here. Corresponding to x 3, so I will be getting 0.06, so might be I am here, and corresponding to your x 4, so I have got 0.08, so I could be here. Now, the original the fuzzy set, so the discrete fuzzy set is something like this. So, as it is discrete, so I am not going to draw any continuous curve, and if I just multiply by d, so I will be getting this type of nature. That means, there is a chance of variation of this particular the distribution. Now, remember one thing, so this particular concept might be required if you want to optimize the shape and size of this particular the membership function distribution. Because what we do is initially we assume some membership function distribution, but we do not know whether that is the correct one, and with the help of some optimizer and with the help of some training scenarios, what we do is we try to optimize the shape of that particular the membership function distribution. And this is actually the physical significance of your multiplication of a fuzzy set by some crisp number. So, I think this particular idea is clear to you. Now, I am just going to consider the power of a fuzzy set. Now, the power of a fuzzy set, that is defined as your A p x, and this indicates actually the pth power of the fuzzy set A x. Now, the moment we are considering the pth power of the fuzzy set A x, so it will have the membership value that is denoted by mu A p x, and mu A p x is nothing but mu A x raised to the power p. Now, p is actually the power, and where small x belongs to the universe of discourse, that is the capital X. Now, if I consider say a particular value for this particular the p, supposing that p is set equal to 2. Now, this is known as the concentration of the fuzzy set. So, if I put p is equals to 2, this is known as the concentration of a fuzzy set. For example, say I have got a fuzzy set x. Now, if I say that can you please find out the concentration of this particular fuzzy set. So, what you will have to do is you will have to find out a raised to the power 2 x. So, this is nothing but the concentration of a fuzzy set. On the other hand, if I set p is equals to say half, that is called the dilation of a fuzzy set. So, for the fuzzy set x, if I tell you that can you please find out the dilation of a fuzzy set, and that is nothing but is your a raised to the power half x. So, this is nothing but the dilation of a fuzzy set. Now, I am just going to consider some numerical example just to show how does it work, and after that I will try to find out what should be the physical significance of this particular concept of power of a fuzzy set. Now, let us consider the same discrete fuzzy set denoted by A x is equal to x 1, 0.1, x 2, 0.2, x 3, 0.3 and x 4, 0.4, and let me consider the power is equal to 2. So, this is nothing but the concentration of a fuzzy set. Now, this A 2 x is nothing but x 1. So, what you will have to do is you will have to find out 0.1 raised to the power 2 square of that, and that is nothing but 0.01. So, corresponding to x 1 we will have to write down 0.01. Similarly, corresponding to x 2. So, what you will have to do is you will have to write 0.2 square, that is nothing but 0.04. Then corresponding to x 3, it will be 0.3 square, that is your 0.09, and corresponding to x 4, actually what we will have is 0.4 raised to the power 2, and that is nothing but is your 0.16. So, this is the way actually we can find out the concentration of the fuzzy set. Now, I am just going to discuss its physical significance. Now, let us try to find out the philosophy behind this particular the concept. Now, once again let me draw a fuzzy set, like if this is your mu, and let me consider this is 0.0, this is 0.4, say this could be 0.1, 0.2, and this is your 0.3, and along this we have got x, and supposing that this is x 1, this is x 2, this is your x 3, and this is x 4. Now, corresponding to x 1, so I have got 0.1. Similarly, corresponding to x 2, so I have got 0.2, and corresponding to x 3, say I have got 0.3, and corresponding to this x 4, say I have got 0.4. So, this is actually the fuzzy set A x. Now, we will try to find out what should be its concentration. Now, concentration corresponding to your x 1, it is 0.01. So, very near to 0. Corresponding to x 2, it is 0.04. So, I could be here. Corresponding to x 3, it is 0.09. So, I could be here, and corresponding to x 4. So, this is nothing but 0.16. So, this is 0.1. So, might be I am here. Now, this is actually the concentration of this particular the fuzzy set, and once again the purpose is actually to find out the optimal distribution of this particular the fuzzy set. Now, once again we can take the help of one optimizer, and with the help of some training scenarios or the training data, we can find out what should be the optimal the distribution of a particular the membership function or a particular the fuzzy set. So, this is actually the physical significance of this particular concept of the power of a fuzzy set. Now, I am just going to find out how to find out your the algebraic sum of two fuzzy sets. Say I have got two fuzzy sets A x and B x defined in the same universe of discourse. So, its their algebraic sum is nothing but A x plus B x is nothing but x, such that it has got the membership value mu A plus B x. So, this will be the membership value, and x belongs to capital X, where mu A plus B x is nothing but mu A x plus mu B x minus mu A x multiplied by mu B x. Now, let us see, let us try to solve one numerical example corresponding to this. Now, supposing that I have got two fuzzy sets. Now, one is your A x is nothing but this is a discrete fuzzy set, and I have got another discrete fuzzy set which is nothing but B x, and B x is nothing but your x 1, 0.5, x 2, 0.7, x 3, 0.8, and x 4, 0.9, and A x I have already used several times the same fuzzy set. Now, how to find out? So, this A x plus B x. Now, as I told that to find out the membership value corresponding to x 1. So, what you will have to do is you will have to add. So, this particular membership function value to this particular membership function value, and then we will have to subtract this multiplied by this. So, what you can do is, so 0.1 plus 0.5 minus 0.1 multiplied by 0.5. So, that will be actually the mu corresponding to this particular the x 1. So, this is nothing but 0.6 multiplied by 0.05, and this is nothing but 0.55. So, corresponding to x 1, so we have got the membership function value 0.55. Similarly, corresponding to this x 2, so I have got 0.2 here, 0.7 here. So, 0.2 plus 0.7 minus 0.2 multiplied by 0.7. So, it is 0.14. So, this is nothing but 0.9 minus 0.14, and this will become equal to your 0.76. So, corresponding to this x 2, so I will be getting 0.76. Similarly, corresponding to x 3, it will become 0.3 plus 0.8 minus 0.24. So, this is nothing but 1.1 minus 0.24, and this is nothing but 0.86. So, you will be getting 0.86. Similarly, by following the same method corresponding to x 4, so I will be getting 0.94. So, this is the way actually we can find out. So, a x plus b x. Now, the next operation is known as the bounded sum of two fuzzy sets. So, once again I have got two fuzzy sets like your a x and b x. They are defined in the same universe of discourse that x belongs to your capital X, and I will have to find out a x bounded sum. So, this is the symbol for the bounded sum. So, a x bounded sum b x, and this is nothing but x such that it has got the membership value which is nothing but mu a bounded sum b x. And how to determine? So, this particular mu a bounded sum b x. So, this is the way actually you can find out. So, this is nothing but the minimum between two quantities, one is 1 and another is your mu a x plus mu b x. So, what we do is we simply add the two mu values and we compare with 1 and we will be taking the minimum. Now, let us see how does it work, and let me solve one numerical example here for this bounded sum. Now, supposing that a x is a fuzzy set, the discrete fuzzy set like this, and b x is another discrete fuzzy set like this. So, what you will have to do is, so you will have to find out the minimum between 1 and what you will have to do is you will have to add. So, this particular mu value and that particular the mu value. So, 0.1 plus 0.5. So, it is 0.6 and we will have to find out the minimum, and that is nothing but 0.6. So, corresponding to x 1, so I will have to write down 0.6. Similarly, corresponding to x 2, so it is nothing but the minimum between 1 and 0.2 plus 0.7 is your 0.9 and the minimum is your 0.9. So, corresponding to x 2, so you will have to write down the membership value as 0.9. Now, following the same procedure for this particular x 3, so this will become minimum between 1 comma. So, 0.3 plus 0.8. So, this is nothing but 1.1 and minimum is nothing but 1.0. So, here you will have to write down 1.0. Similarly, corresponding to this x 4, so this is nothing but the minimum between 1 and 0.4 plus 0.9. So, this is nothing but 1.3 and you will have to find out the minimum, that is your 1.0. So, corresponding to this particular x 4, so we are writing 1.0. So, this is the way actually we can find out the bounded sum of your a x and b x. Now, let us see how to carry out the algebraic difference between the two fuzzy sets. Now, supposing that I have got the two fuzzy sets like a x and b x, and they are defined in the same universe of discourse, that is x belongs to capital X. So, how to find out the algebraic difference, that is your a x minus b x. Now, a x minus b x is nothing but x such that it has got the membership function value, that is your mu a minus b x. Now, how to define this mu a minus b x? The mu a minus b x, that is defined as mu a intersection b bar x. So, what I will have to do is, so I have got two fuzzy sets a x and b x. So, we have got a x and b x. So, what you will have to do is, you will have to find out the complement of this particular b, and that is nothing but is your b bar x. So, this is the complement of b x, and after that we will have to use the concept of intersection, that is your a intersection b bar. Now, let us see how does it work, and just to show. So, I am just going to solve one numerical example. Now, supposing that your a x is nothing but a discrete fuzzy set something like this, and b x is another discrete fuzzy set something like this. So, what we do is, we try to find out its complement, that is b bar x is nothing but x 1 comma 1 minus 0.5, that is 0.5. So, I will be getting 0.5 here, then x 2 corresponding to this x 2, and this will be your 1 minus 0.7, that is nothing but is your 0.3, then corresponding to this particular x 3. So, this will become 1 minus 0.8. So, this is 0.2. So, I will be getting this as complement, then corresponding to this x 4. So, this is nothing but 1 minus 0.9, and this is nothing but 0.1. So, I will be getting this. So, this is nothing but the complement of b. Now, actually what we do is, we try to find out the intersection of this particular a x with your b bar. Now, if I try to find out the intersection of a x and this particular your b bar, so a x intersection, so b bar I am just going to find out. Now, element wise, so I will have to find out what should be the mu. Now, corresponding to this x 1, so what I will have to do is, I will have to compare. So, this 0.1 with your 0.5, and we will have to consider the minimum, and that is nothing but 0.1. Then corresponding to x 2, so I have got 0.2 and I have got 0.3 here. So, minimum of that is 0.2. Then corresponding to x 3, so I have got 0.3 here and 0.2 here, and the minimum is 0.2. Then comes your corresponding to x 4. So, I will have to compare 0.4 and 0.1, and the minimum is your 0.1. So, this is the way actually we can find out what should be your a x minus b x. So, this is the way we can find out the difference. Now, then comes your the bounded difference between the two fuzzy sets. Now, let us see how to find out the bounded difference of two fuzzy sets. Now, the two fuzzy sets are nothing but a x and b x, and we try to find out the bounded difference. Now, this particular symbol is actually the symbol for the bounded difference, okay, and this is nothing but x, such that it has got the membership function value, which is nothing but a bounded difference b x, x belongs to capital X. Now, how to define this particular the membership? Now, this mu a bounded difference b is nothing but the maximum between two quantities, one is 0 and another is your mu a x plus mu b x minus 1. So, what you will have to do is, you will have to add mu a x and mu b x, you will have to subtract minus 1. So, this particular quantity you will have to determine, and we will have to compare with 0, and we will have to find out the maximum. Now, let us see how does it work. Let us solve one numerical example. Now, if we just solve the numerical example, so you can find out, say I have got two fuzzy sets here. I have got two fuzzy sets here. One is nothing but is your A x, another is your the B x, and we will have to find out the maximum between 0 and so this particular mu minus 1, that is your 0.1 plus 0.5 minus 1.0, and we will have to find out the maximum of this, and this is nothing but is your the maximum between 0 and here it is 0.6 minus 1. So, it is your minus 0.4, and the maximum between 0 and minus 0.4 is nothing but 0. So, corresponding to this particular x 1, so I will have to write down 0.0. Then corresponding to x 2, so what you will have to do is, so you will have to find out the maximum between 0, 0.2 plus 0.7 minus 1.0. So, this is nothing but the maximum between your 0.9 minus 1.0. So, this is nothing but minus 0.1 and the maximum value is 0. So, corresponding to x 2, so there will be 0.0. Then corresponding to x 3, so what we will have is your the maximum between 0, then 0.3 plus 0.8 is 1.1 minus 1. So, this is nothing but 0.1 and the maximum between 0 and 0.1 is nothing but 0.1, and corresponding to your x 4. So, this will be your maximum between 0, 0.4 plus 0.9 is 1.3 minus 1.0. So, this is nothing but 0.3 and the maximum between 0 and 0.3 is nothing but is your 0.3. So, we can find out, so this particular your A x bounded difference your the B x. Now, let us see how to find out the Cartesian product of two fuzzy sets. Now, let me consider that I have got two fuzzy sets, say A x, that is defined in the universe of discourse capital X, and I have got another the fuzzy set that is B y, that is defined as another universe of discourse. Now, this A x might be the set of temperature in a month for the first few days. So, that is nothing but the A x, and B y could be the values or the collection of values of say the humidity of a particular place, and where y is nothing but the collection of all humidity values. So, I have got two universe of discourses, one is x, another is y, one could be temperature, another could be humidity, and A x is defined in x and B y is defined in y. So, how to find out the Cartesian product of these two fuzzy sets? The Cartesian product of these two fuzzy sets is defined as mu A Cartesian product B x comma y is nothing but the minimum between mu A x comma mu B y. So, what you will have to do is, so I will have to compare so these two mu values and we will have to consider the minimum. Now, let us see how does it work. Now, supposing that say I have got two fuzzy sets, one is your A x and I have got another fuzzy set in another universe of discourse, that is say B y. So, how to find out their Cartesian product? So, what we will have to do is, so we will have to find out the minimum of mu A x 1 comma mu B y 1. So, I will have to compare. So, that is nothing but the minimum. So, mu A x 1 is 0.2 and mu B y 1 is 0.8. So, we compare 0.2 and 0.8 and we try to find out the minimum. Similarly, we will have to compare. So, mu A x 1 comma say mu B y 2, that means I will have to compare your the 0.2 and 0.6, 0.2 and 0.6 and their minimum value is nothing but 0.2, and by following the same procedure. So, I will have to find out the other elements, that is your the minimum between mu a x 1 and mu b y 3, that is the minimum between 0.2 and 0.3, and that is nothing but 0.2. Next is the minimum between mu a x 2 comma mu a y 1, that is nothing but the minimum between 0.2 and 0.8, and that is nothing but is your 0.3. Next is the minimum between mu a x 2 comma mu b y 2, and that is nothing but the minimum between 0.3 and 0.6, and that is nothing but 0.3. The next is the minimum between mu a x 2 and mu v y 3, and that is nothing but the minimum between 0.3 and 0.3, and the minimum is your the 0.3. The next we try to find out the minimum between mu a x 3 comma mu b y 1, and that is nothing but the minimum between 0.5 and 0.8, and that is 0.5. Next is minimum between mu a x 3 comma mu b y 2, following the same procedure I will be getting 0.5. Then comes your minimum between mu a x 3 and mu b y 3, and that is nothing but the minimum between 0.5 and 0.3. So, I will be getting 0.3 here. Next is the minimum between mu a x 4 and mu b y 1, and that is nothing but minimum between 0.6 and 0.8, and you will be getting 0.6. Now, here, so this your the product. To find out the products, we need to find out some other elements like your the minimum between mu a x 4 comma mu b y 2 is nothing but the minimum between 0.6 and 0.6, it is 0.6. Then comes your the minimum between mu a x 4 mu b y 3, that is nothing but is your the minimum between 0.6 and 0.3, and you will be getting 0.3. Now, this particular product we can write down, and that is nothing but, so in the matrix form. So, all the elements I have already determined. So, this I can write down in the matrix form, and this will look like this. So, this will become actually your, so there will be your 4 rows and 3 columns. So, this is nothing but a 4 cross 3 the matrix. So, this is actually the product of A and B. Thank you.